Hello everyone. Sound is a form of energy which produces a sensation of hearing in our ears and helps us interact with nature and surroundings. So, today, let us discuss something more related to this in our lesson Sound. Sound is a form of energy which gives sensation of hearing to us. Sound is produced due to vibration of a body. It is a form of mechanical energy. Sound is produced by vocal cords of human beings, birds and animals, bell, vehicles, musical instruments, etc. Propagation of sound. The sound produced by a vibrating object travels through a medium to a listener. The medium can be solid, liquid, or gas. When an object vibrates, the particles around the medium vibrates. The particle in contact with the vibrating object is first displaced from its equilibrium position. It then exerts a force on the adjacent particle and the adjacent particle is displaced from its position of rest. After displacing the adjacent particle, the first particle comes back to its original position. This process repeats in the medium till the sound reaches the ears. The disturbance produced by the vibrating body travels through the medium, but the particles do not move forward themselves. Since sound waves are produced due to the vibration of particles of the medium, sound waves are called mechanical waves. Propagation of sound through air. Air is the most common medium through which sound travels. When a vibrating object moves forward, it pushes and compresses the air in front of it, forming a region of high pressure called compression. The compression moves away from the vibrating object. When the vibrating object moves backward, it forms a region of low pressure called rarefaction. As the object moves to and fro rapidly, it produces a series of compressions and rarefaction in the air which makes the sound to propagate in the medium. Sound needs a medium to travel. Sound is a mechanical wave and it needs a medium of propagation. Sound travels through solids, liquids, and gases. Sound does not travel in vacuum. Sound waves are longitudinal waves. Sound propagates in a medium as a series of compressions and rarefactions. In these waves, the particles move back and forth parallel to the direction of propagation of the disturbance. Such waves are called longitudinal waves. There is another kind of waves called transverse waves. In these waves, the particles oscillate up and down perpendicular to the propagation of the direction of disturbance. Activity. Stretch a slinky and push and pull it alternately at one end. If you mark a dot on the slinky, the dot moves back and forth parallel to the direction of the propagation of the disturbance. Characteristics of a sound wave. Sound wave can be described by its frequency, amplitude, and speed. Sound can be graphically represented as a wave. There is changes in the density and pressure as sound waves in a medium. Compressions are the regions of high pressure and density where the particles are crowded and are represented by the upper portion of the curve called crest. Rarefactions are the regions of low pressure and density where the particles are spread out and are represented by the lower portion of the curve called trough. The distance between two consecutive compressions or two consecutive troughs is called wavelength. It is represented by the symbol lambda. Its SI unit is meter. Frequency of a sound wave. When sound is propagated through a medium, the density of the medium oscillates between a maximum value and a minimum value. The change in the density of the medium from a maximum value to a minimum value and again to the maximum value is one oscillation. The number of oscillations per unit time is called the frequency of the sound wave. It is represented by the symbol mu. Its SI unit is Hertz. Time period of sound wave. The time taken for the change in the density of the medium from a maximum value to a minimum value and again to a maximum value is the time period of the sound wave. Or the time taken for one complete oscillation in the density of the medium is called the time period of the sound waves. It is represented by the letter T. The SI unit is second. Frequency and time are represented as follows: mu for one oscillation, T is equal to 1 upon mu, or mu is equal to 1 upon T. Amplitude of a sound wave. The magnitude of the maximum disturbance in the medium on either side of the mean value is the amplitude of the sound wave. Or the amplitude of the sound wave is the height of the crest or trough. It is represented by the letter A. The SI unit is the same as that of density or pressure. Pitch and loudness of sound. The pitch of sound depends upon the frequency of vibration. If the frequency is high, the sound has high pitch, and if the frequency is low, the sound has low pitch. The loudness of sound depends upon the amplitude of the vibration. If the amplitude is bigger, the sound is loud, and if the amplitude is smaller, the sound is soft. Speed of sound. The speed of sound is different in different media. The speed of sound is more in solids, less in liquids, and least in gases. The speed of sound also depends on the temperature of the medium. If the temperature of the medium is more, the speed of sound is more. Relationship between speed, frequency, and wavelength. Speed is equal to wavelength multiplied by frequency. Have a look at speed of sound in different media at 25 degrees Celsius. Reflection of sound. Like light, sound gets reflected at the surface of a solid or liquid and follows the laws of reflection. The angle of incidence is equal to the angle of reflection. The incident ray, the reflected ray, and normal at the point of incidence all lie in the same plane. Echo. If we shout or clap near a reflecting surface like a tall building or a mountain, we hear the same sound again. This sound which we hear is called echo. It is caused due to the reflection of sound. To hear an echo clearly, the time interval between the original sound and the echo must be at least 0.1 seconds. Since the speed of sound in air is 344 meter per second, the distance traveled by sound in 0.1 second is equal to 34.4 meter. So to hear an echo clearly, the minimum distance of the reflecting surface should be half this distance, that is 17.2 meter. Reverberation. Echoes may be heard more than once due to repeated or multiple reflections of sound from several reflecting surfaces. This causes persistence of sound called reverberation. In big halls or auditoriums, to reduce reverberation, the roofs and walls are covered by sound absorbing materials like compressed fiber boards, rough plaster, or draperies. Uses of multiple reflection of sound. Megaphones, horns, musical instruments like trumpets, shehnais, etc. are designed to send sound by multiple reflection in a particular direction without spreading in all directions. Doctors listen to sounds from the human body through a stethoscope. The sound of heartbeat reaches the doctor's ears by multiple reflection. Generally, the ceilings of cinema halls and auditoriums are curved so that sound after multiple reflection reaches all parts of the hall. Sometimes a curved soundboard is placed behind the stage so that sound after multiple reflection spreads evenly across the hall. Range of hearing. Human beings can hear sound frequencies between 20 Hz and 2000 Hz. Sound whose frequency is less than 20 Hz is called infrasonic sound. Animals like dogs, elephants, rhinoceros, whales, etc. produce and hear infrasonic sound. Sound whose frequency is more than 2000 Hz is called ultrasonic sound. Animals like dolphins, bats, rats, porpoises, etc. produce and hear ultrasonic sound. Bats use reflection of ultrasonic sound waves to detect an obstacle or its prey. Uses of ultrasonic sound. Ultrasonic sound is used to clean objects like electronic components. The components to be cleaned are kept in a cleaning solution and ultrasonic waves are sent into the solution. Due to the high frequency, the dirt particles get detached from the components. Ultrasonic sound is used to detect cracks in metal blocks. Ultrasonic waves are sent through the metal blocks, and if there are cracks, the waves are reflected back and the cracks can be detected. Ultrasonic sound is used in ultrasound scanners for getting images of internal organs of the human body. Ultrasonic sound is used to break small stones formed in the kidneys into fine grains so that they are removed through the urine. Sonar. Sonar stands for Sound Navigation and Ranging. It is a device which uses ultrasonic waves to measure distance, direction, and speed of underwater objects. Sonar has a transmitter and a detector installed in ships. The transmitter produces ultrasonic sound waves which travel through the sound and after striking the object in the seabed is reflected back to the detector. The distance of the object can be calculated by knowing the speed of the sound in water and the time taken between the transmission and reception of ultrasound. If the time taken for the transmission and reception of ultrasound is t and the distance traveled is 2d by the ultrasound, then 2d is equal to v multiplied by t, or d is equal to v multiplied by t upon 2. Structure of the human ear. The outer ear called pinna collects the sound waves. The sound waves passes through the ear canal to the thin membrane called eardrum. The eardrum vibrates. The vibrations are amplified by the three bones of the middle ear called hammer, anvil, and stirrup. The middle ear then transmits the sound waves to the inner ear. In the inner ear, the sound waves are converted into electrical signals by the cochlea and sent to the brain through the auditory nerves. The brain then interprets the signals as sound. So, this was all about our lesson sound. Sound is all around us in our everyday lives. It is important to be able to communicate with others, to learn, to be informed, and to have sound for enjoyment. So, studying about it is very important. Thank you, students.